Okay. Yeah. Good evening, everyone. Myself, I am Faaiz. I am from AIMS Nagpur. So yeah, we are continuing our PYQ discussing series for JEE mains. Okay. So yeah, let me start. This is our first question. Yeah, the question is: a conducting loop of radius is 10 by root pi centimeter is placed perpendicular to a uniform magnetic field of 0.5 Tesla. The magnetic field is decreased to 0 in 0.5 second at a steady rate. The induced EMF in the circular loop at 0.5, 0.25 second. Okay. So the induced EMF we can write as d5 by dt, right? Okay, everybody know that. So it is a perpendicular uniform magnetic field. So the magnetic field is decreased to 0.5 second at a steady rate. So change in flux will be first we have B into A. And the next is magnetic field decreased to zero, right? So flux. The question is 5 second. Right. Yes. And for that we have to find out now BA. So for BA, the area is, we know that pi into r square, correct? Pi into radius is given 10 by root pi. So if we, okay, in the centimeter, 10 square by root pi square will be pi square. No, root pi square will be, let me write again. Radius is 10 by root pi. So അതിന്റെ square എടുത്താൽ 100 divided by pi into 10 raised to minus 4. Correct. So pi we can cut. So area is how much? 10 raised to minus 2. Area is 10 raised to minus 2. So it will be magnetic field is 0.5 Tesla. Correct. So 5 into 10 raised to minus 1 into 10 raised to minus 2 divided by 5 into 10 raised to minus 1. So we can cut this. So our induced EMF is getting as 10 raised to minus 2 volt. ബട്ട് ഓപ്ഷൻസ് ഏതാണ്ടത് മില്ലി വോൾട്ടിൽ. സോ മില്ലി വോൾട്ടിലേക്ക് മാറ്റണമെങ്കിൽ നമുക്ക് എങ്ങനെ എഴുതാതിനെ 10 മില്ലി വോൾട്ട് എന്നെഴുതി കൂടെ? കറക്റ്റ് അല്ലേ? സോ ഓപ്ഷൻ 2 ആണ് കറക്റ്റ് ആൻസർ ആയി വരുന്നത്. മൂവിംഗ് ടു നെക്സ്റ്റ് ക്വസ്റ്റ്യൻ. എ മെറ്റാലിക് റോഡ് ഓഫ് length L is rotated with an angular speed of omega normal to a uniform magnetic field B about an axis passing through one end of rod as shown in the figure. The induced EMF is okay. Again, okay. So this is the scenario. Let me draw here. Okay. This is the scenario. Okay. We have a rod. Correct. We have a rod which is rotating in a perpendicular magnetic field. Correct. So it is rotating omega angular velocity. So at a distance x from the from the axis, at a distance x, let me take a small portion of length dx. Correct. So for this portion, the velocity will be correct. V is equal to r. So for that portion, induced EMF is dE will be how much? B omega x BLV, correct? dx. So you have to find out whole, right? So you have to integrate this. So by integrating, you will get the total induced EMF. That will be how much? B omega integral x dx from 0 to rod in the length of L. So L. B L square omega, half B L square omega, half B L square omega. Option number 3 അല്ലേ ഇതെല്ലാം യൂസ് ചെയ്യുന്നത് B L square omega. Correct, yes. Moving with 88 meters per second at a right angles to a magnetic field of 2 Tesla. The magnitude of induced EMF between the ends of the wire will be between the ends of the wire. We know that induced EMF across the end എന്താണ് formula എന്താണ് induced EMF across the ends. We know that how much B L V. So just values കൊടുത്താൽ മതി നമുക്ക് കിട്ടും 2 ടെസ്ല ലെങ്ത് എത്രയാണ് ലെങ്ത് 1 മീറ്റർ ആണ് അല്ലെ കറക്റ്റ് അല്ലേ 1 മീറ്റർ ആണ് സോ 1 വെലോസിറ്റി മൂവ് ചെയ്യുന്ന conducting material is stretched into a circular loop. It is placed with its plane perpendicular to uniform magnetic field B equal to 0.8 Tesla. When released, the radius of the loop starts shrinking at a constant rate 2 centimeter. Okay, centimeter inverse. The induced EMF in the loop at an instant when the radius of the loop is 10 centimeter will be. So it's very simple. Elastic conducting material is stretched in a circular loop. Correct. So the flux എത്രയായിരിക്കും ആ circular loop ഉണ്ടാവുന്ന flux എത്രയായിരിക്കും ഇടാം simple അല്ലേ B into area will be pi r square. Correct. And we know induced EMF is what? Yeah, d phi by dt. So ഇതിനെ ഡിഫറൻഷിയേറ്റ് ചെയ്ത് എന്ത് കിട്ടും b pi 2r dr by dt. Correct. So എല്ലാ വാല്യൂസ് നമുക്ക് ഗിവൺ ആണ് അല്ലേ ബി എത്രയാണ് 0.8 8 into 10 raised to minus 1 പൈ എത്രയാണ് 3 അപ്രോക്സ് 3 എടുക്കാണ് റേഡിയസ് r എത്രയാണ് 6 at the instant when the return centimeter. So 10 into 10 raised to minus 2 dr by dt 2 centimeter inverse 2 upon 10 raised to minus 2 വെട്ടാൻ പറ്റും ഇതും വെട്ടി ആൻസർ എത്ര വരുന്നത് ആൻസർ കിട്ടുന്നത് 2 into 5 into 0.1 into 3 2 into 10 raised to minus 2 നമുക്ക് 2 പൈ into 1 അപ്രോക്സിമേറ്റ് ചെയ്താൽ 10.06 കിട്ടും അപ്രോക്സ് നമുക്ക് ഇടാൻ ഇടാം 10 എഴുതാം ഓക്കെ കറക്റ്റ് യെസ് നെക്സ്റ്റ് ക്വസ്റ്റ്യൻ ആസ് പെർ ദ ഗിവൺ ഫിഗർ if di by dt is minus 1 ampere per second then the value of VAB at this instant will be. So it's simple, right? So let me start from VA. So VA minus okay, ഇതിലൂടെയുള്ള പൊട്ടൻഷ്യൽ ഡ്രോപ്പ് എന്തായിരിക്കും മൈനസ് ഐ ആർ കറക്റ്റ് ഇവിടെ ഇതിലുള്ളതോ പൊട്ടൻഷ്യൽ ഡ്രോപ്പ് എൽ ഇൻറ്റു ഡി ഐ ബൈ ഡി ടി കറക്റ്റ് ഇവിടുന്ന് ഇവിടെയും ഡ്രോപ്പ് ആവില്ലേ ഇങ്ങനെയല്ലേ വരുന്നത് പോസിറ്റീവ് ടു നെഗറ്റീവ് to find out what VA minus VB. So VA minus VB will be how much? IR plus L into di by dt plus E. IR is how much? 24. 6 into minus 1 plus 12. So how much? 36 minus 6. It is 30 volt. So answer will be 30 volt. Correct? Yeah. Moving to next question. An inductor of 0.5 millihenry, a capacitor of 20 microfarad, and a resistance of 20 ohm are connected in series with a 220 volt AC source. If the current is in phase with the EMF, the amplitude of the current of the circuit is root XA. The value of X is in phase. In the resonance, we can write as what? XL equal to XC. Impedance will be just the resistance only, that is 20 ohm. Correct. So I can write RMS current as 220 divided by 20. That will be how much? 11. And we know that I max will be how much? 11 root 2, which is actually root 242. So our answer will be how much? 24. Okay. Yes. Okay. Okay. Let's solve question number 3. Okay. A common transistor radio set requires 12 volt DC for its operation. The DC is constructed by using a transformer and a rectifier circuit, which are operated at 220 volt AC on standard domestic AC supply. The number of turns of secondary coil are 24. Number of turns of primary coil. Okay. How do we solve this? ഇതൊക്കെയാണ് തന്നാ നോക്കാം നമുക്ക് അല്ലേ ഗിവൺ ഇതൊക്കെയാണ് ഗിവൺ വാല്യൂസ് നോക്കാം ഗിവൺ പ്രൈമറി വോൾട്ടേജ് ഗിവൺ ആണ് അല്ലെ പ്രൈമറി വോൾട്ടേജ് that is VP is 220 volt and secondary voltage is also given. Secondary voltage VS is given how much? 12 volt. Correct. Number of turns in secondary coil NS is 24. Next, number of turns in primary coil NP. അതിൽ നമുക്ക് കാണേണ്ടത് എങ്ങനെ കാണാം? We have the equation correct. എന്താണ് നമ്മുടെ കയ്യിലുള്ള equation? NP by NS equal to VP by VS. So NP we can write as VP by VS into NS. Just values കൊടുത്തു. VP എത്രയാ? 220. VS so 12. NS so 24. Correct. So 2. So how much number of turns in primary coil will be 440. So our answer will be 440. Correct. Yeah. Next question. A coil of inductance 2 Henry having negligible resistance is connected to a source of supply whose voltage is given by V to 3T. If the voltage is applied when T equal to 0, then the energy stored in the coil after 4 seconds is how much joule? Okay, very simple. We can solve like this. See, another induced EMF equal to L into di by dt. Correct. It is given that which is equal to 3T. So I can write that L di by dt equal to 3T. So L di equal to 3T dt. So by integrating this L into integral di 3 integral t dt. I can write as Li equal to 3 t square by 2. Correct. And we will get equation for current as 3t square by 2L. Okay. Next is what? Energy. Energy E is half L I square. Is equal to half L I square means 9 t raised to 4 divided by 4L square. ഓരോ വാല്യൂസും കൊടുത്തോ. What happened? Yeah. Okay, this is guys right. Yes. So we go to for current equal to is by 2. And we know that energy equal to half L square. So question energy will be half L 9 t raised to 4 by 4L square. So ഓരോന്നിന്റെ വാല്യൂ കൊടുത്താൽ നമുക്ക് ആൻസർ ഹാഫ് എനർജി ലാസ്റ്റ് നമുക്ക് കിട്ടിയത് എനർജി ഈക്വൽ ടു ഹാഫ് L 9t raised to 4 by 4L square. Correct. 9t raised to 4 by 4L square. ഒന്നുകൂടി ലൈക്ക് L കട്ടായി പോകത്തില്ലേ? 9t raised to 4 by 4L. So values കൊടുത്തോ half 9 by 4. T square എത്രയാണ്? 4 second. So 4 into 16 into 16. L 3 L 2. Correct. 4 4 4 4 4. Okay. Here on the last 4 16 into 9. 16 into 9 how much? 9654. Answer will be 144. Okay, yeah. Moving to next question. An aeroplane with its wings spread 10 meter is flying at a speed of 180 km per hour in a horizontal direction. The total intensity of earth field that field is 2.5 10 raised to minus 4 Weber per meter square and the angle of tip is 60 degree. The EMF induced between the tips of the plane wings will. ഓക്കെ, എങ്ങനെ ചെയ്യുന്നത് കാണിച്ചു തരാം. Yes, so we know that used EMF is perpendicular into VL, correct? Okay, dip is 60, it's given. So yeah, this is total magnetic field. This is vertical component. This will be 60 degree, correct? So we can write as sin 60 equal to BV by P, correct? Or root 3 by 2 equal to BV by B, or BV equal to root 3 by 2 into B. So induced EMF will be how much? Equal to root 3 by 2 B into L into B, correct? BV is the perpendicular magnetic field. So root 3 by 2 magnetic field is total given how much? 2.5 into 10 raised to minus 4. ഇനി നമുക്ക് ഇവിടെ നമുക്ക് ജസ്റ്റ് ഇവിടെ സോൾവ് ചെയ്യാൻ പറ്റും. എന്ത് കിട്ടി? ഇൻഡ്യൂസ്ഡ് EMF ഈക്വൽ ടു root 3 by 2 B L V. Root 3 by 2 B is 2.5 into 10 raised to minus 4 into length L is given how much? 10 meter. 10 into V 180 kilometer per hour. So അതിനെന്താക്കണം? മീറ്റർ പെർ സെക്കൻഡിലേക്ക് മാറ്റണ്ടേ? 180 into 5 by 80. So 10, 50. Correct. So ചെയ്താൽ നമുക്ക് എന്ത് കിട്ടും? 2, 2, 25. 25, 25, 625. 625 root 3 into 10 raised to minus 4. 625 root 3. Root 3, root 3 1.7 അല്ലേ? 0.7. 625 into 1062. 1062 into 10 raised to minus 4. There will be how much? 0.1 volt. Millivolt ആക്കിയാലോ? അപ്രോക്സ് മില്ലി വോൾട്ട് ആണ് വേണ്ടത്, മില്ലി വോൾട്ട്. പിന്നെ 10 raised to 3 കൊടുക്കാം. അപ്രോക്സ് എത്ര വരും? 106 മില്ലി വോൾട്ട്. 106 മില്ലി വോൾട്ട്. 106. നേരത്തെ വാല്യൂ 1 അല്ല, ഇതല്ലേ ഓപ്ഷൻ 4 ആണ്. കറക്റ്റ്. യെസ്, കറക്റ്റ്. Yeah, moving to the next question. Circular display for magnetic field 3 minus 5 Tesla. Its plane perpendicular to the field initially. It's rotated at a constant angular speed about an x along the diameter of coil perpendicular to magnetic field. So that it undergoes half of rotation in 0.2 second. The maximum value of EMF induced in microvolt in the coil will be correct. എങ്ങനെ ചെയ്യുന്നത് നമ്മള് നോക്കിക്കോ. First, let's find what is omega. Omega is what? Yeah, omega is 2 pi by t, correct? Yes. 2 pi by t. 2 pi by half rotation in 0.2 second. Total time will be 0.4, correct? So omega will be pi by 0.2. Omega കിട്ടി അല്ലേ? ഫ്ലക്സ് എന്തായിരിക്കും? ഫ്ലക്സ് phi will be pi dot a will be how much? B cos omega t, correct? It's rotate. So differentiate ചെയ്താൽ induced EMF കിട്ടൂലേ? E dphi by dt will be equal to how much? AB omega sin omega t, correct? Maximum value എത്ര? മാക്സ് വാല്യൂ ഓഫ് induced EMF എത്ര വരിക? അല്ലേ നമുക്കറിയാലോ. AB omega, correct? Area is pi r square B omega. ഓരോന്റെ വാല്യൂസ് കൊടുത്തു പോകാം, ആൻസർ കിട്ടും. പൈ ഈസ് 3.14. റേഡിയസ് ഇസ് ഹൗ മച്ച്? 10 സെന്റിമീറ്റർ. 10 centimeter means 10 to the minus 1, 10 to the minus 2 square. B is how much? 300 raised to minus 5. 300 raised to minus 5. Omega is again pi by point fact. So ഇവിടെ നമുക്ക് അതിൻ്റെ ഒരു പൈ ഉണ്ട് അല്ലേ? So pi square നമുക്ക് 10 ആക്കി എടുക്കാം അല്ലേ? 10. 10 10 raised to minus 2 into 300 raised to minus 5. 200 raised to minus 1. Correct. So by 2 into 10 raised to 1. Correct. Yes. So ഇതും കട്ടാക്കാം. 10 raised to minus 7. 3 by 2. 1.5 into 10 raised to minus 7 volt. നമുക്ക് മൈക്രോ വോൾട്ടിലല്ലേ ആൻസർ വേണ്ടത്. സോ നമുക്ക് 1.5 into 10 raised to minus 7 into 10 raised to 6 മൈക്രോ വോൾട്ട് എന്നത്. കറക്റ്റ്. ഇത് എത്ര വന്നു? Yes. Moving to next question. Two concentric circular coils C1 and C2 are placed in the xy plane. C1 has 500 turns in radius of 1 centimeter. C2 has 200 turns and radius is 20 centimeter. C2 carries a time-dependent current, 5t square minus 2t plus 3 ampere, where t is in second. The EMF induced in C1 in millivolt the instant equal to 1 second is 4 by x. Value of x is അങ്ങനെ കാണുന്നത്. നമുക്ക് ഓരോ തന്ന വാല്യൂസ് നമുക്ക് ഓരോന്ന് കഴുതാം. കറക്റ്റ്. So coil C1, number of turns N1 is 500 and radius R is 1 centimeter. For coil C2, number of turns N2 is 200 and radius, that is capital R, we can write as 20 centimeter. Current is given 5t square minus 2t plus 3. So by doing dA by dt will be how much? 10t minus 2. So 5. Flux in small coil will be how much? B into A. That will be how much? Magnetic field will be mu naught I by 2R. Correct. The number of turns, that is N2. Correct. Into pi R square for small. Correct. So induced EMF in small coil will be how much? d5 by dt. It is mu naught N2 by 2R pi R square into N1 into di by dt. Correct. So നമുക്ക് എന്ത് കിട്ടി? mu naught N2 N1 pi R square by 2R. di by dt എന്താ? 10t minus 2. Correct. So നമുക്ക് ലാസ്റ്റ് കിട്ടുന്നത് ഇൻഡ്യൂസ്ഡ് EMF E as നമുക്ക് എന്ത് കിട്ടും? ലാസ്റ്റ് 4 mu naught N1 N2 pi R square by R. വാല്യൂസ് കൊടുത്താൽ നമുക്ക് വാല്യൂസ് കൊടുത്താൽ 4 into mu is 4 pi into 10 raised to minus 7 N1, okay, N1 N2 200 into 500, correct, into 10 raised to minus 4 by 10 raised to minus 2 pi by 20. Last is x കിട്ടുന്നത് 5 ആണ്. X will be how much? 5. X will be how much? 5. Okay, yes. Let's solve this question. A thin ring of 10 centimeter radius carries a uniformly distributed charge. The ring rotates at a constant angular speed of 40 pi radian per second about its axis, perpendicular to its plane. If the magnetic field at its center is 3.18 10 raised to minus 9 Tesla, then the charge carried by the ring is closed. Charge carried by the ring is closed. ഇങ്ങനെ കാണുന്നത്. Correct. Okay, go. Current will be charged by time. We can write this like this in terms of omega. Correct? Yes. Magnetic field is center at center mu naught I by 2R. So current is mu naught I by 2R. Current we can write Q omega by 2 pi. Correct. Solve with omega charge. Q is 3 into 10 raised to minus 5 coulomb. 3 into 10 raised to minus 5 coulomb. That is option 2. 3 into 10 raised to minus 5 coulomb is the right answer. Yeah, moving to next question. The figure shows a square loop L of side to the work of resistances. The whole setup is moving towards right with a constant speed of 1 centimeter per second at some instant a part of L. Magnetic field of 1 Tesla perpendicular to the pin of the loop if the resistance of L is 1.7 ohm. The current in the loop at that instant will be closed. We know that induced EMF will be how much VLV, correct? Will be how much 1 into 10 raised to minus 2 into 5 into 10 raised to minus, that will be 5 into 10 raised to minus 4. അല്ലേ കറക്റ്റ് അല്ലേ? ഇതിന്റെ ഇക്വലന്റ് റെസിസ്റ്റൻസ് വേസ്റ്റേൺ ബ്രിഡ്ജ് ആണ്. സോ 2 1 കറക്റ്റ് അല്ലേ? എത്രയും മാറും 4 2 4 into 2 4 plus 2 ഓക്കെ പ്ലസ് 1.7 കൂടി ആഡ് ചെയ്യണം. എത്ര കിട്ടുന്നത്? അപ്രോക്സ് 3 ഓം വരും. അപ്രോക്സ് 3 ഓം വരും. 3 ഓം. സോ കറന്റ് വിൽ ബി ഹൗ മച്ച്? EMF by resistance. EMF is 5 into 10 raised to minus 4. Resistance is 3. So approximate കിട്ടുന്നത് 170 micro ampere. 170 micro ampere. Next, a power transmission line feeds input power at 2300 volt to a step down transformer with its primary windings having 4000 turn. The output power is delivered at 230 volt by the transformer. If the current in the primary of the transformer is 5 ampere and its efficiency is 90%, the output current would be. We know that efficiency eta is how much? Yeah, output power divided by input power. So I can write output power by input power as VSIS divided by VPIP. Correct. So efficiency is given that 90%. So it will be 0.9 will be equal to 230 into IS divided by primary 2300 into 5. Correct. From this we will get IS 5 into 9, 45 ampere. 45 ampere. Okay. Next question. The self-induced EMF of a coil is 25 volt. When the current in its change at uniform rate from 10 ampere to 25 ampere in 1 second, the change in the energy of the inductance is energy is half Li square, correct? Yeah. Induced EMF is by Faraday's law, d5 minus d5 by dt, correct? Will be equal to L di by dt, which is equal to 25. From this, we will get L into 15 by 1 equal to 25. So L will be how much? 5 by 3 Henry, correct? Next is change in energy of the inductance. That will be change in energy will be half L into A1 square minus I2 square. So I can write half into 5 by 3, 25 square minus 10 square. Change in energy will be how much? 5 by 6 into 525. It's coming out as 437.5. Correct. Next question. There are two long coaxial solenoids of same length L. The inner and outer coils have radii R1 and R2 and number of turns per unit length is N1 and N2 respectively. The ratio of mutual inductance to the self-inductance of the inner coil is. So we know that the rate of mutual inductance is given by the rate of mutual inductance is given by M equal to mu naught N1 N2 by R1 square. Correct. Next. The rate of self-inductance is given by L equal to mu naught N1 square PR1 square. So by taking ratio, M by L will be N2 by N1 and 2 by N. Option 4 will be the correct answer. Next, last question. A 10-meter long horizontal wire extends from northeast to southwest. It is falling with a speed of 5 meters per second at right angles to the horizontal component of its magnetic field of 0.3 unit 10 raised to minus 4 Weber per meter square. The value of the induced EMF in wire is the value of the induced EMF in wire is how much induced EMF is how much induced EMF equal to BVL, correct, is equal to 0.3 into 10 raised to minus 4 into 5 into 10. So this will be 1.5 into 10 raised to minus 3. That is option 1 will be the correct answer. Option 1 will be the correct answer. Easy, yes. Moving to this question. Upper value is found on a wooden frame whose shape is that of an equilateral triangle. If the linear dimension of each side of the frame is increased by a factor of 3, keeping the number of turns of the coil per unit length of the frame the same, and the self-inductance of the coil is correct as total length L of the wire will remain constant. So L will be 3AN, correct? So self-inductance will be how much? Mu naught N square AL. Square by 4 into L. That is self-inductance directly proportional to A square N. So A increased to 3A. So self-inductance will become 3 times. So 3 times. Option 3 will be the correct answer. Okay, yes. Bye guys.